Yes, P6 learners, welcome to this online teaching program. My name is Mr. Mugisha Emmanuel. In our previous lesson, we looked at how we can apply more about direct proportions in different questions, and I took you through a variety of questions. And at the end of my lesson, I gave you an activity which I hope you did so well. But before I take you through today's lesson, allow me go through two numbers in the activity which I gave you. That is number 4 and number 6. Okay? So can we remind ourselves? Number 4 says a car consumes 8 liters of petrol for every 80 kilometers. How many liters are required to cover a distance of 120 kilometers? I told you here, you can use formula method or the other proportions. So here we can say new out of old, then times the quantity. So identify what has been given twice. We have liters, we have kilometers, then here again we have kilometers. So which one has been given twice? Of course, kilometers. So which one is new? 120 kilometers. We divide it by old, that is 80 kilometers. Then we multiply by the remaining quantity, which is 8 liters. So kilometers with the kilometers will go. This 0 will go with this. We can cancel by 8 once, by 8 once. So we have remained with 12 times 1 liter, which is going to give you 12 liters. Okay? And we have also number 6. A tray of eggs contains 30 eggs. How many trays will one get from 630 eggs? If we are using the same method, new, we are looking for number of trays in how many eggs? 630. So 630 eggs becomes new. You divide by, a tray has 30 eggs, then times the quantity, and the quantity is a tray. So when I say a tray, how many trays are those? 1. That is 1 tray. So eggs will cancel off. This one will go with this by 3 once, by 3, that is 21. So we are getting 21 trays. So basically this is what we looked at in our previous lesson. So in today's lesson, we are going to look at inverse proportions. Inverse proportions. So when we talk about inverse proportions, what is the difference between inverse proportions and direct proportions? You are going to observe the difference as we go through this number. 5 children take 4 minutes to sweep the class. How many minutes will 10 children take to sweep the same class working at the same rate? I've said 5 children take 4 minutes to sweep the class. How many minutes? So we are looking for minutes. How many minutes will 10 children take to sweep the same class working at the same rate? So since we are looking for minutes, it means on my left-hand side we should have children. So this side we have children. And what am I looking for? Time, which is in minutes. Okay. So 5 children take how many minutes to sweep this class? They are 4 minutes. 5 children take 4 minutes to sweep the class. And I told you that before we go to 10, we are supposed to first of all get 1. What about when it is 1 child? So 1 child takes, here you just need to use common sense. When when you are 5 and I tell you to sweep the class, you will take 4 minutes. What about when you are 1? Are you going to take less than 4 minutes? Somebody is saying yes. You are 5, you take 4. What about when I tell you to sweep it alone? I think the burden will have to increase, so you will take more than 4 minutes because you don't have people to help you to sweep this class so that you finish it very fast. So it means you will have to take the time the 5 people will take times 4 minutes. When you are alone, 5, you will take 4. When you are alone, it will be 5 times 4 minutes. What about when I increase now from 1 to 10 children? 10 children. So 10 children will take, you get the product, this one will be 20 minutes. When it is 1, it is 10, it is 20 minutes. What about when it is 10? Are you going to take more than 20 minutes? No. This time you are going to share. Since you are working together, you divide this now by 10. So this one will go with this. So it means when you are 10 children, you are going to take only 2 minutes. So have you seen the difference? Whereas in direct proportion, when I reduce here, this one will also reduce. But we have seen that when you reduce this side, for inverse proportion, instead this side will increase. Let's look at another example. Let's look at another example. 4 builders take 6 days to build a house. Okay? How long will 12 builders take to build the same house but working at the same rate? So we are saying 10 builders take 6 days to build a house. When they are 4, they will take 6 minutes. They will take 6 days. What about if I increase the number of builders to 12? How long will they take? So for this case, we are looking for time. So we shall have builders this time, this side. Then we shall have the number of days they will take. Okay? So when there are 4 builders, they will take how many days? 6 days. Now this time I want to use only one builder. One builder. So do you think one builder will take less than 6 days? When you are 4, you take 6. So what about when it is one builder? This builder is going to take more than 6 days. So one builder will take 4 times 6 days. Okay? What about if I increase from 1 builder to 12 builders? Twelve builders will take, the product here is 24 days. But since they are now 12, they will divide this one, they will share. So by 12 once, by 12 2. So it means when there are 12 builders, they are going to take only 2 days. We are going to take 2 days. Let's look at another example whereby the workers are this side. Let's look at an example whereby we need to look for number of workers. For example, 9 boys can slash the compound in 6 days. Now this time I'm saying how many? How many boys are needed to slash the same compound? How many boys are needed to slash the same compound in this time 2 days? Okay? 9 boys can slash the compound in 6 days. How many boys? So we are looking for boys. How many boys are needed to slash the same compound in 2 days? So instead of beginning with the boys, this time we shall begin with days. So we shall say days, then boys. Why do I write boys last? Because we are looking for number of boys. So, how many days? We have said 6 days. 9 boys can slash the compound in 6 days. So we say 6 days need. 6 days need how many boys? 9 boys. What about if it is now 1 day? Do you need more boys to do it in 1 day, or you need less boys? Of course you will need more boys so that they do it in 1 day. So it is going to be 6 times 9 boys. What about if I increase now from 1 day to 2 days? So 2 days need 6 times 9. Then we divide it by 2. And what are these? Boys. Then you can reduce. You can multiply this and get one product. Or you can divide when it is still in multiplication form. So divide by 2 once. 6 divided by 2, 3. So it means 2 days will need 3 times 9 boys. And this one will give you 27 boys. You see? Okay, let's look at another example. Let's look at another example. Another example, we are saying 10 workers can do a piece of work in, let's have another example. 10 workers can do a piece of work in 6 days. How many workers are required to do the same work in 20 days? 10 workers can do a piece of work in 6 days. How many workers? So it means we are looking for the number of workers. So on this side we shall have days. Yes, days. And on this side we shall have workers. Okay? So 6 days require how many workers? There are 10 workers. What about if I want this work to be done in 1 day? So this one will require more workers. So it is going to be 6 times 10 workers. What about if I increase from 1 to 20 days? So these ones will reduce the burden. So it is 6 times 10. Then we divide by 20. You can multiply and get 60 workers. So this 0 will go with this. Then by 2 once, by 2, 3. So it means 20 days require 3 workers. They require 3 workers. And lastly, 12 women take 5 hours to weed a garden. How long will 20 women take? How long will 20 women take to weed the same garden? So what are we looking for? 12 women take 5 hours to weed a garden. How long? When I say how long, in this case, what do I need? I need time. So we shall have time this side, then women this side. Women, then hours, because we are looking for hours. So 12 women take 5 hours. What about if it is 1 woman? So 1 woman takes longer time. That will be 12 times 5 hours. What about if I increase from 1 woman to 20 women? These ones will take 12 times 5 hours, then we divide it by 20. So by 5 is 1, by 5 is 4. Then by 4 is 1, by 4 is 3. So they will take 3 hours. I hope you have seen the difference between direct proportion and indirect proportion. In this case, when we give you questions about indirect proportion, when you reduce this side, the other side increases, which is different from direct proportion. Because in a direct proportion, when you increase this side, even the other side increases. That's what makes a difference between a direct proportion and indirect proportion. Thank you very much for your time. I'm going to give you an exercise. Please do that work so well. Write it very well in the Kampala Quality Cursive. I wish you well.